Today we're going to be taking some notes on writing linear equations. A couple things we need to add in. There's a little bit of vocabulary here. So a best fitting line is going to be a line that lies as close as possible to the points of a scatter plot. And we're going to have to talk about what a scatter plot is coming up here. So it's the line that lies as close as possible to the points of a scatter plot. And we're going to be referring to this throughout our notes, so that's why we're putting that guy in right now. All right, so let's look at example 1. Example 1 says, write an equation of a line with a slope of -2 and a y-intercept of -5. Well, this is a review of last chapter. You did this last chapter. So we know that this is the m, and this is the b, and all we have to do is plug them in their spot. So y equals a -2x plus 5. And we'll just rewrite here y equals -2x plus 5. They left us room to simplify if we needed to simplify our slope, for example. We don't. All right, the next one, here's a checkpoint. So what I want you to do is I want you to pause, and then I want you to come back and see if you have the same answer as I do. All right, so you should have gotten y equals 4x plus -3, or you could have had 4x minus 3. The m was 4, and the y-intercept was -3. Going down to example 2, you're going to write an equation by looking at the graph. We also did some of this last unit. So first of all, we need to find the slope. They left us room here to do the formula for slope or just the counting method. And I'm going to do the counting method because it's quicker. If they give us a picture, why not? So slope is rise over run. So the rise direction here is 2, and the run direction is 3. They're both positive. Rise over run. So the slope of my line is 2/3. Okay, you could have also used the formula for slope y2 minus y1 over x2 minus x1 and gotten the same answer. The y-intercept is the place where the line crosses the y-axis, which happens to be right here, and that's 0, 2. So my y-intercept, my b, is 2. So then I just need to plug them into my equation. So y equals 2/3 x plus 2 is the equation for that graph. The next type of example is without a picture. So they say write an equation of a line that is parallel. Oops, we just did that parallel exploration. Good thing. Parallel to the line y equals x. And then there's a part B. So let's not worry about part B. Let's focus on this one where we have to write a parallel equation. Well, here's my equation right here. And the slope of that line is what? The slope of that line is 8. So I know the parallel line to that one is also going to have a slope of what? 8. So the parallel line is y equals 8x, and now I just need to find my new b. But look at what they did. They were so tricky. They gave you the b already. The point 0, 3, where is that? That's on the y-axis. X is 0, so that is the y-intercept right there. So all I have to do is write plus 3. So that one wasn't too bad after all. The next question, question B, says write an equation of a line that is perpendicular. Okay, so think about what that means for slope. To this line, y equals a -12x plus 3, and passes through the point 0, -5. So our given slope is a -0.5. Now a reciprocal line is going to have, or a perpendicular line is going to have a negative reciprocal slope. So the negative reciprocal of that would be 2 over 1, and it would be positive because it was negative there. Well, 2 over 1 just simplifies to 2. They also gave me the y-intercept right here. Now look at, there's a typo. So they gave it as a -5, and then down here when they wrote it, what did they write? +5. So we'll change it to a negative because that's what they had in their original problem. So the perpendicular line will pass through negative 5. That's going to be my B. So my new equation is y equals the new slope we found of 2x plus the y-intercept they gave us was negative 5. All right, so down at the bottom there's a checkpoint. You should be able to do all 3 of those checkpoints based on the notes that we've already done. Go ahead and pause and take your time to do those and then come back and see if we have the same answer. All right, so let's see how you did on that. The first one, they didn't give us a graph this time. They only gave you the ordered pairs. So either you graphed it and then you counted out rise over run, or you used our old friend, the formula for slope, which is y2 minus y1 over x2 minus x1. The slope you end up with is 2. The y-intercept they gave you at negative 3, so it's y equals negative 2x plus 3. Now we're to our friend, the parallel guy. We know parallel means same slope, so our slope of our new equation is 3, and they gave us the new y-intercept of 4, so our equation is y equals 3x plus 4. The last one was a perpendicular line. The slope of the given equation was 3. The perpendicular slope is a negative third. The new b is a negative 2, so it's y equals negative 1/3 x plus negative 2. Okay, so if you had trouble on those, see Mrs. Wyman, or you can replay notes, but those should have been pretty easy to do on your own, maybe just a minor mistake here or there. Our last page of notes has to deal with the scatter plot and the best fitting line that we had been talking about before, and why we would need all of these equations that we've been finding. So what we're going to do right now is we're going to make a scatter plot of the data. They give us some data here, and it says teachers. The table shows the number of elementary and secondary school teachers in the United States for the years 1992 to 1999. So it's years since 1992. So 0 years since 1992 would be 1992. 1 year since 1992 would be 1993, and so on. So here's our years since, and here's our teachers in 10,000. Okay, so we would multiply those numbers by 10,000 to get the actual number, but that would be crazy to graph those big numbers on a graph, so they simplify it for us. So part A says to approximate the equation of the best fitting line. Well, we have to first graph this data to see if we can get a best fitting line. So what we're going to do there is we're going to graph out each one of these, and we have to kind of approximate. So it would be 0, 282, 1, 287, 2, 293, 3, 298, 4, 305, 5 is 313, 6 is 322, and 7 is 330. So it's not a perfectly straight line. It shouldn't be a perfectly straight line. So what we are going to do is we're going to make the line of best fit. We're going to draw a line using our ruler, trying to make it fit as best as possible. And we don't connect the dots. We actually draw a best fit line. So I'm going to have to go something like this, a little above, a few a little below. Probably could have even been up a little bit higher, but you get the idea. It's not touching each one perfectly. Okay? So there's our scatter plot. We've drawn it in. And then it says to find the slope, we're going to find 2 points on the line. Now they've picked 2 for us, 0, 280, and 7, 330. It's not on my line perfectly. I'm going to use those 2 because those are the ones that they have for an example. But I should have picked probably this guy's right on the line nicely. And then I don't really have any other that are perfectly on the line. So I would probably use this point, this intersection point of 300. Those 2 would help me to get the best line of fit. We'll use these because you probably have some different points than I have, so we'll just use these and know that we would have used the others if we were doing this on our own. So slope is y2 minus y1 over x2 minus x1. We have to find the slope of this line in order to write the equation. So we would have 330 minus 280 over 7. All right, minor delay of the phone there. Continuing on, so now we have 7 minus 0 on the bottom. this ends up being 50 over 7. And see these little approximately signs? We're going to just round that, and we're going to round it to the nearest hundredth. So when you put it in your calculator, it ends up being 7.14 or 7.14. So the line intersects at 280 roughly is where it's going to intersect if I would have continued my line. I think it intersects right there at 280. So what is that point? That's the y-intercept. Okay, and this isn't a perfect scientific method like matched exactly. This is line of best fit. Doesn't say exact line, it says line of best fit, so we're doing our best here. So then to write that equation, we would use our slope, which we just calculated as 7.14, our x, and then plus our y-intercept where it crossed at 280. Okay, then part B says to predict in 2006. What do you think it would have been back in 2006? Well, 2006 is 14 years since 1992. So we have to first do that. To get from 1992 to 2006, it was 14 years. So 14 is what we're going to be plugging in for x. So we take our new equation. It's 7.14. We plug 14 in there, add the 280 to see what happens. And when we type that into our calculator, we get 380. And was it exactly 380? Thousands? 38,000 teachers? No. In 2006, we have to multiply this by 10,000. All right, so I went and got my calculator so you could see this because it's in 10,000. So it's not 380, it's not 38,000. It's 380 times 10,000. Okay, so that ends up being 3,800,000 teachers. We plug in our commas, it's easier to read. 3,800,000 teachers in the United States. Obviously, there wouldn't be 38 teachers, and there wouldn't be 380 teachers or 38,000 teachers. So that's how you use a line of best fit to predict. We could have also extended it out. Okay. Now, if we have time, I'm going to show you how to do this whole process on your graphing calculator and get the exact prediction, not just the line of best fit. But we'll save that for another day. Okay, so you are going to be continuing on to the next step and going forward in your packet.